Snowden students, hope you're having a great day. Today we're going to be talking about some statistical analysis. Our objective is to apply chi-square test to data to determine if there is a significant relationship. Now before we can talk about a chi-square test, we needed to talk about categorical variables and degrees of freedom. Categorical variables are a value with two or more categories, but there is no intrinsic ordering of the categories. They take on values that are names or labels. For example, you can have race, gender, age group, educational level, hair color, eye color. You could have breed of dog, blood type, political party, type of rock, language. These are examples of categorical variables. In our example, say we have a population, and we're going to have two categorical values, blue or green. This is categorical because it's two or more categories, but there is no intrinsic ordering of categories. And say we already know that this population is 60% blue and 40% green. Now, in our population, we need to determine the degrees of freedom. This is how many times you can choose between two choices or two categories, or the maximum number of values that have the freedom to vary. In order to determine the degrees of freedom, you take the number of categories, in this case blue or green, and you subtract 1. So for us, the degrees of freedom is blue or green, 2 minus 1. Degrees of freedom is going to be 1. Now let's move on to the chi-square test. This is a test to test if a sample is similar or different from the population. In Google Sheets, it'll return a p-value. If this value is greater than 0.05, then we accept the null hypothesis, which means that the expected is the same as the observed, or the sample is similar to the population. If it's less than 0.05, then we reject the null hypothesis, and the expected is not the same as the observed, and the sample is not similar to the population. Now, there's a formula involved in the chi-square test. It looks like this, but we're going to break it down in Google Sheets. So we have our population, and we know that the population is about 60% blue and 40% green. Now we want to take a sample of the population. This is our sample. And from our sample, we see that there's going to be 6 blue and 6 green. Now this sample that we took is our observed value. This is what we observed in the sample. However, we know from previous experience that we are expecting the population to be 60% blue and 40% green. So now we'll go to Google Sheets. This is in Google Classroom. And under the observed, we're going to put that we observed 6 blue and 6 green. Now, we've collected our observed samples. These are the steps for chi-square test. We need to take the sum of the observed samples because we're going to use that to determine what to put in the expected column. So we can just do equals sum these two. Now, the expected column, even though we know the percentage of the expected, we need it to equal the same sum as the observed. So we can't use percentages. Instead, we need to take the percentage, 0.06, and multiply it by the sum of the observed. So we do equals the sum of the observed times the percentage. And we'll do that here too. And now when we take the sum of the expected, they both equal 12. If they don't equal the same number, the test is not going to work. Now, we're going to break down this formula. The first thing that we need to do is take the observed, O, and subtract the expected. So this is our observed. So we're going to take this value minus the expected. And we're going to do the same for the next one. this one. Then we're going to square it. So we take what we found and we square it. Then we're going to take this value and we're going to divide it by the expected. Divided by the expected. And the same thing here. This divided by the expected. And finally, we're going to sum the results. So now we get this chi-square value, but we don't know the p-value yet. In order to determine the p-value, we're going to use a formula called chi-distribution. So really quick, we've determined what the expected sample size was, we applied the mathematical formula, and now we have summed the final values. In order to do the chi-distribution, we need to determine the degrees of freedom. We already showed that two values, blue and green, to get the degrees of freedom, we take those two and we subtract 1, so 2 minus 1 is 1. So our degree of freedom is just 1. So for chi-distribution, we do chi-distribution, here it is. We need to put x is the value, or the sum, and the degree of freedom is 1. Now it returns 0.479, or 0.48. If this value is above 0.05, then the sample size is similar, the sample is similar to the population. If it's below, the sample is not similar to the population. So we've determined, because it's 0.5, which is greater than 0.48, which is greater than 0.05, then we would accept the null hypothesis, because the sample is similar to the population, because it's greater than 0.05. Alright, so this sample we took is similar to the whole population. Sounds good. But what if we try something else? What if we take this sample? I mean, we don't know that we're taking this sample, we're just making it a random sampling, but what if we take this sample and we conclude that there's 12 blue and 0 green? Remember, from this sample, this is what we observed, the 12 blue and 0 green, and this is what we expect, 60% blue and 40% green. Well, in order to determine if this sample is similar to the whole population, even though it might seem obvious, we need to do a chi-square test. So we have 12 blue and 0 green. So we'll apply the chi-distribution. Our value is going to be, oops, I can't see it, 8. Here, G12. We know the degree of freedom is 1. So now our result is 0.0046. This is less than 0.05, so the sample is not similar to the population. 0.004. After performing the chi-square test, the p-value is 0.0046, so we reject the null hypothesis. The sample is not similar to the population. This is telling us that there's something going on with this sample that makes it different from the population. Now there's another way that you can calculate the chi-test, and it's a lot less intensive than this. All you need are the expected and the observed values. So another way that we can calculate square is instead of doing equals chi-distribution, you do equals chi-test. And this will essentially do the mathematical equation for you. So you would do equals chi-test. Now it asks first for the observed range. Well, our observed range, what we sampled is here, comma. Now the expected range, here. This returns the same value that we got for the chi-distribution in the beginning, and it's a much easier way to find the p-value. And we'll do that here too. Our observed first is this, and our expected. 0.046. So now there's two ways of finding p-value for the chi-square test. In conclusion, in this lesson we learned how to apply a chi-square test to a sample, and we learned how to determine if the result is significant or not. If you have any questions, please email Dr. Duran or myself, and I hope you enjoyed this video. Thank you.